Hi, this is the video for Year 1 Mechanics, and we're looking towards exercise 10C. Now it's really important here that we understand the difference between the weight and the mass of something. Essentially, the mass, if you like, is the amount of stuff. So not the volume, but the amount of stuff, how big something is, and it's measured in kilograms. The weight is the force of the acting on the mass. So it's the result of gravity acting on the mass. And it's measured in newtons because every force is measured in newtons. Now, the definition of a newton, 1 newton will cause 1 kilogram to accelerate at a rate of 1 meters per second. That's how it's defined. Newton's second law says the force acting on a particle is equal to the product of the mass and its acceleration. So 1 newton being the force, 1 kilogram being mass, and 1 meter per second being acceleration. Of course, we know that the acceleration due to gravity is g. So a special case of this, weight equals mass times acceleration due to gravity. So weight is mg. So if I'm ever told that a particle has a mass of 5 kilograms, I know straight away that the force due to gravity, i.e. the weight, is 5g. And I need to get used to this. If I'm ever told that I'm given a mass, then I need to put the weight on my force diagram, whether or not I'm explicitly told to, because that weight will always be the same, and it will always act vertically downwards. And we'll talk about more about non-vertical forces next year. So first of all, we need to appreciate the difference between mass and weight, and understand that gravity is a specific value of acceleration. With all that in mind, example 5 gives us mass, it gives us the force, and it asks us to find the acceleration. So Newton's second law, F equals ma, 6 equals 1.5a, so a must be 4 meters per second squared. And we're not particularly bothered about direction in this basic example. We are bothered about direction for example 6. Example 6 gives us a diagram. It gives us a mass of 2 kilograms. It tells us, in fact, it does this bit for us, doesn't it? 2g. There's some force acting vertically. There's some force acting horizontally, and there's a force acting opposite in the opposite horizontal direction. Now, it also tells us, and A is always indicated with a double arrow, that A is 2 meters per second in this horizontal direction. I always call that positive. Okay, what I'm going to do, and get used to this, we do this a lot, I'm going to, I would say, resolve horizontally. That's how I'd say it. What I mean is apply Newton's second law in the positive horizontal direction. And I write, I'm going to resolve horizontally. And as a reminder, the subscript T means total force, because I've actually got 2 horizontal forces. Ft equals ma. Horizontally, I've got a positive force x and a negative force 4, so x minus 4 equals my mass times my A, so my force must be 8 newtons. That's part A. I haven't done vertically. If I resolve vertically, well, I'm told my acceleration is purely horizontal, so my vertical acceleration is 0. Again, up is positive, so I'm going to resolve vertically, which means apply Newton's second law in the positive vertical direction. Y minus 2g equals mass times acceleration, which is 0. So y must equal 2g. I've just got space to fit there. 19.6. It's a force, so it's newtons. Okay, resolving vertically and resolving horizontally and resolving vertically is basically everything else in mechanics. I need to get my head around this skill, but it is the same every time. For part B, I'm still going to treat right as positive and up as positive, because I always do. It's just a bit more complicated. So I've got my mass, which means even if I didn't have it given, I'd write my weight there. Got a vertical force there. There's another vertical force acting downwards. That's interesting. I've got a horizontal force x and a horizontal force 80. And this time I'm told my acceleration is acting to the left. So by my definition, it's a negative acceleration. Remember, always positive is across, positive is to the right and positive is up. So I'm going to resolve horizontally, resolve vertically, just as I did last time. Resolve horizontally, a reminder to myself that means Ft equals ma. Horizontally, x minus 80 is mass times by negative acceleration. So x will be 72 newtons. And resolving vertically, I've got an extra force here, doesn't matter. Again, remind myself what I mean by resolving. Positive 20 is negative, 4g is negative, and I have 0 vertical acceleration, and that's often the case because we're often dealing with a particle sitting on a table. Equals mass times acceleration. So that means that y equals 20 plus 4g, 59.2 newtons to 3 SF. This is a really important skill, resolving using Newton's second law. They're both the same, they both mean the same thing, but we do it a lot, and most of our marks in our mechanics are going to come from resolving forces. So you need to get your head around this. If you need to pause, rewind, email me, whatever, get your head around this resolving. Okay, example 7, you can see it's basically the same thing. Let's have a quick look at the example. Now, it hasn't told me anything about the weight, but I already know the weight. The mass is 5 kilograms, so straight away I've got a weight of 5g. Remember, I've got this force that is the table pushing up. We call it the reaction force. That's the force that's stopping it falling through the table. And common sense says R is going to be equal to 5g, but we'll prove that with Newton's second law. I've got a force to the right, a force to the left, and I'm just going to resolve and solve, as I always do. Resolve and solve, rhymes, never thought of that before. Reminder that right is positive, up is positive. I'm told it's accelerating to the right, and I've got to find out what A is. So let's resolve horizontally. Again, a reminder of what that means. 20 minus 4 equals 5a. Nice, easy. So I've found out the acceleration. What's it asking me? The distance travelled by the body in the first 4 seconds. Well, that's suvat since a doesn't change. So get used to topics being mixed up. S equals ut plus a half at squared. S is what I want. I start, now the question says the body is initially at rest, so u is 0. A I've just worked out, so half of 3.2, so that's 1.6 times by 4 squared. 25.6 meters. And part C, the normal reaction. Now, the wording is they're very careful to word this so that it doesn't matter which direction you've chosen as positive. The magnitude of the normal reaction, if you like, you can choose down as positive, in which case R would be a negative force. It doesn't care about the sign. It just wants the size, the magnitude. I don't know why you choose down as positive, but you can, I suppose, if you wish. So, resolving upwards, remember that's apply Newton's second law. I've got R minus 5g. I have 0 vertical acceleration, so I can see R equals 5g, which, you know, we used common sense and said, well, it must equal 5g. 49 newtons. If I had a negative value for R here because I'd defined downwards as positive, then I'd state that magnitude equals 49, but since it's already positive, then I'm good. Okay, have a go at 10C. Let me know if you need anything. See you next time.